So today we will start with the introduction to course. In between, if you face any problem, let me know. Now tell me, slide is visible or not? Okay, thank you. Thank you. Okay, so this course name is probability and random process, and someone may see that somewhere you may get the name of this course probability and random processes because several process uh, people used to discuss in this course. So what my approach would be here. Random process I will discuss from the Gaussian process perspective. So Gaussian process is more generalized random process, and most of random process are happens to be a special cases of the Gaussian process. That's why I have given name probability and random process. So coming to outline of today's lectures, first I will give a brief introduction of course information. There I will talk about course logistic and assessment process and references and other kind of things. Then I will start with this course itself. By today, I will introduce what is the probability, why we are studying probability, and in different scenario how we observe probability and why probability is very much essential to a study. So it is one kind of uh, thing that we need to measure a randomness or uncertainty. So probability is providing a very interesting tool to measure uncertainty or randomness. So that's why from that perspective, I will discuss probability in detail. And then I will go to discuss about random experiment because most of the experiment, if you try to look around yourself, always happens in random in nature. So if experiment happens to be random in nature, then it would be really very difficult to measure or quantify that random experiment. So there must be a logical or axiomatic approach to quantify random experiment. So such kind of experiment I will discuss in detail and what are those that logical thing or axiomatic thing, so which help in quantifying a random experiment. Those things we'll discuss. And at last, also in this lecture, when we try to quantify a randomness in a random experiment, what we do, we need to introduce some kind of a probability measure, or it is just a probability, it is just a number that lies between 0 and 1. So we will introduce this probability. We simply call it a measure. So we always, and in short also you can say that it is just a probability of an event. So probability of an event always it happens between lies between 0 and 1. So this kind of things we will introduce in this course. So coming to course information, so I have already mentioned that name of this course is probability and random process, and if you are willing to ask code of this course is MA 203. And this course you may find as a prerequisite of many of your courses in electronics and communication. So that's where you have to be very good in this course and be attentive. My suggestion would be, so what is the objective and outcome of this course? So there are many remarkable progress you can see in engineering science using computational techniques from probability and random process. Those things we will see it here. Objective of this course is that how we can solve problem from engineering using technique from probability and random process. It is all about that. It is objective of that. So further you can say that this objective you can say that in a twofold way. I just try to unify things from computational mathematics perspective. So here we have to develop a solid understanding of probability and random process technique. With these computational technique, we have to study few new result and its application to communications. Mostly in electronics and communications, you all are solving problem from communication domains. So we will try to apply those technique to solve a communication problem. So that would be application part of this course. I will take you an interesting example as well. So outcome would be that you can get you can learn a lot of techniques. So one technique I told that Gaussian process technique. So one technique in linear algebra, many times I told that regression. So regression, it looks a very classical technique. Also, it is very relevant in now in present time as well. But in modern time, there is very interesting kind of regression technique that we are calling it Gaussian process technique. Or if you try to explain that Gaussian process technique optimization perspective, then that we are calling it Bayesian optimization. So those are very interesting kind of modern machine learning technique, or simply you can say that surrogate modeling technique to get practical solution of a problem. So those things we will discuss in detail, and this course also it will help to it will definitely help in your higher academic higher academy or higher study as well, and also in industrial life as well. So coming to course link of this course, so I have already shared everything in the mail in previous in last day. So you can say that Google link for this one is given here. This is the Google link, Google Classroom link. Then if you are willing to join Google Classroom, those who haven't joined, my suggestion would be join as soon as possible, because everything, whatever information would be there regarding this course, I will put that there in the Google Classroom. So you all have to uh, join that Google Classroom. And for joining the Google Classroom, code is already given here. This is the code of joining Google Classroom. This only for this classroom. And also you can say that there is a common Google Meet link, but always some kind of recording issue might be there. Google Meet, which is already there in the Google Classroom. So rarely I will use this Google Meet. Sometime if there is issue, then I may go for this link. And always what you do, use institute mail id for best use of G Suite, because you will get a lot of space in G Suite on G Drive. That's why my suggestion would be always use your institute mail id. Okay, so coming to syllabus of this course, syllabus I have already divided this one into four module. uh, that in first module I will discuss about elementary probability. So it is not much difficult. It would be what you will see that whatever probability you have already studied in plus 2, so same elementary probability would be extension of that. So you will feel that just it is one uh, link between what you have already studied probability in 12th and what you have to start here in this course. So it is just elementary probability. I will give a comprehensive explanation of elementary probability and how we can utilize this in incoming module. So it is very much essential to recall elementary probability from class 12. Also, I will give some modern perspective. I have already mentioned that I never believe in rote learning. I always believe in understanding kind of things. So from that perspective, I will try to give a lot of intuition to understand elementary probability in this model. Coming to model 2 is all about probability distribution. So it is very important part of this course. You know that whether you are studying machine learning, whether you are studying control theory or system identification, always what you do, you always try to learn a function, or you try to learn a decision boundary. So what kind of things? So all things happens to be distribution in nature. So when someone is saying that I am doing a machine learning, I am learning a function. So actually that person is trying to learn a distribution of the data. The data, whatever data in hand, you as an input you used to have data. So you try to learn a function so that you can say that that data is coming from that function, or simply you can say that you try to learn a distribution. So if you are having a very good idea of distribution, then you can understand machine learning and other courses. So that's way. So I will give a very interesting, again, intuitive explanation of all possible probability distribution, and how we can get application of this probability distribution in order to get some complex distribution as well. So so in detail we will discuss generally two type of probability distribution. One would be discrete probability distribution that is dealing with categorical variable. Another one is what continuous probability distribution. So those kind of distribution we will discuss in detail here in module 2. So coming to module 3 is all about large sample theory and statistical inference. So this technique is what people actually calling this technique. It is a classical way to understand or a classical way of machine learning. You can say that in what in at the beginning of statistics, people what they used to do, they used to uh, get inference from the given data set from this large sample theory. So that's where this large sample theory and statistical inference both are coming in together. So this one is also very important from what statistical inference or simply in decision making. So model 3 will play a very important role in decision making. So if some problem you are having and you have already model a system for that problem, so that means you have already develop a model. So it's fine. You are having a model. Now from that model, how you can utilize that model? That means how can you make a decision based on that model? So if you are very good in large sample theory and statistical inference, then definitely you can make a very good decision. So it is this model 3 is very important from decision perspective. So even sometime in higher study you may see one course on decision theory as well, or information theory. Also information theory need to make some kind of decision. So those kind of courses, if you are very good in large sample theory, you will definitely uh, find very uh, eligible to get a decision or some kind of prediction. Another a simple name of decision, you also very common word that fall in the neighborhood of decision, that we are calling it prediction. So if you suppose you are having a data of uh, some kind of height, weight, or something like that uh, from a population, some part of population, and you try to predict that those persons are whether in healthy category or whether in uh, unhealthy, or whether in so in between only two categories, like healthy and unhealthy. So in that case, what you do, you try to make a decision, you try to draw a decision boundary. And how can you, so you one kind of prediction is happening, or one kind of decision is happening based on the available data of height, weight, and other blood pressure kind of things. So you can say that this person is falling in the healthy category, that person is falling in the in healthy unhealthy category. So you can make a decision based on all those things. Okay, so once we are having enough idea of elementary probability distribution and sample theory, large sample theory, we can discuss, at the end we can discuss random process. So I had already told that here in detail I will discuss Gaussian process. Then I will go to discuss about very simple kind of process that if you anyone everyone might be aware of supermarket concept or new cinema hall concept kind of things. So there, what you observe, always you observe some kind of uh, random process. So very simple kind of random process. It happens to be Bernoulli process, Poisson process. So those kind of things, those kind of random process are very simple to deal that supermarket. Supermarket scenario, or customer arrival or customer departure kind of things. You can discuss, you can solve those problems based on Bernoulli process and Poisson process. So those kind of things we will discuss in random process. So those things. So this is the syllabus of this course. Anyone, if you are having any question, you can any question you can ask. Otherwise, I am going to discuss further regarding assessment and other things. Yes. No, 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 no. Permutation combination, that one would be part of elementary probability. That one is part of we are calling it counting principle. It is not more than you won't see probability kind of things there. It is just helping in counting. It is all these are counting principle. So in elementary probability, those things will come. And definitely, if you, I told that when you are good in elementary probability, definitely those things will be applied there in the random process as well. So while calculating probability, those things are coming. Okay. So those would be very simple. Don't worry about those things. So those just consider as a simple counting principle, not more than that. I will take one lecture over that as well. Okay. Any other question? No. Okay. I'm going forward. Course assessment. So course assessment, again similar pattern what I have already used, same pattern I will use in this course as well. So there would be 4 exams in total. There would be 2 quizzes and 2 terms exam. One would be midterm, another would be enter, apart from assignment and other things. So 50, so marks distribution is like this way: 15% it will be from assignment, class participant or minor project, something like that. Okay, so then I will go to discuss about here. 20% it will be dedicated to quizzes. There will be two quizzes, and syllabus and everything is already mentioned here. Uh, okay, so coming to midterm, 25% is given to midterm, uh, and 40% is given to end term. So all these, I just tweaked this course assessment due to this online process. Otherwise, I rarely used to change this mass assessment. So coming to timetable, I think you all might have got timetable. Did you get timetable or not? Anyone respond? Okay, fine. Then I think there is no issue with timetable. I will stick with that timetable. So here, further, I have already mentioned that there would be assignment, and you have to solve this and submit in Google Classroom. And everything is already mentioned regarding assignment. And timetable is already given here. There would be 3 lectures. This one would be lecture 1, lecture 2, lecture 3, and last class it would be on Saturday. We will talk about tutorial. So Saturday class would be tutorial class. And I have already again given a description of detail of my uh, myself. Uh, you all know that my name is Lakshman Mathur. Here I am working here in as a mathematics instructor. Okay. Regarding email, generally I will use institute mail. This is the email name plus uh, email ID of institute. And this is the home page. You can get a lot of information regarding myself in the home page as well, and previous classes. Apart from that, also you may visit my that YouTube page, YouTube link as well. I have there what after every class I used to upload lectures, recorded lecture there in YouTube as well. So you can further you can watch that lecture as well. And linear algebra is very much essential. It will come when we will start large sample theory and random process. Linear algebra definitely that will come. So try to recall those concepts as well. Reference regarding references. So lecture notes might be it would be sufficient. I think every information would be given in lecture note. Apart from that, if you are looking for textbook, get this textbook, Ross, Sheldon Ross. This one is a very interesting book, stochastic process. This person, Sheldon Ross, he is always writing book in probability and stochastic process and statistics. So he is very good in that field. So, and this book is most referred book. So you can get e-copy of this book easily from the reference, and also in library, central library. I think physically you can access, you cannot access that library. So what you do, you can request from Sagar is a librarian of this institute. He may provide some book, e-copy of this stochastic process. Okay, apart from that, there are some classical textbook on this probability and random process. One is by Grimet. This one is a really interesting book, probability and random process. You can it is published in Oxford University Press. You can get this book, e-copy of this book. This one is really interesting. Why interesting? I'm talking about examples from electronics and communication perspective. So one course is meaningful if you are solving problem from your domain, and that means uh, you all are from electronics and communication, and you are studying a particular course, and you are trying to solve problem from that domain from this course, then definitely this course it will be very interesting for you. So that's way, try to collect this e-copy of this book, because you will get a lot of problems. So a single book can't have all the problems. So you have to look for multiple book for problem perspective. So keep on visiting these problem. Populist is very famous book. I think every electronics and communication person they know about this book. Populist and Pillai. This person has just this is the main person. He had written this book single-handedly. Then this later this Pillai came, uh, by adding he added something new, and this book is really interesting, and most of IITs they are having this book as a textbook. Generally they are taking this book as a textbook for ECS student or electronics sorry electrical student. Okay, so you can get this book as well. This one is also very interesting. And Devonport, this one is also very interesting book. You can get it because my suggestion is that get all these books, and whichever book is suited to you, you can follow that book completely from problem perspective. How much problem you are getting? It is all about solving problem. So read and try to understand a course and solve the problem. So if you are able to solve the problem, then things would be very interesting. Okay. So coming to prerequisite, there is no prerequisite. Most of things I will discuss in this. Whatever things would become would be here. I will try to discuss in the class itself. So it simply I can say that this course is self-contained, and there is no much rigorous requirement of prerequisite. But I hope that you can recall matrix decomposition, poetic form, other things from previous linear algebra class. At least those things just have to recall. Otherwise, definitely I will cover those things again. And from calculus, recall the derivative concept. That means derivative of function of several variables. Then second derivative, if you are dealing with, then that one is always described by Hessian and Taylor's approximation or expansion. These kind of things you will use during distribution and other kind of things. So, and also in central limit theorem. So just recall those things. Okay, and regarding programming language and algorithm, so definitely I will try to put things in algorithmic approach. And regarding programming language, I would like to suggest use R again. R is really very interesting for this course, probability and random process. And even you can get some dedicated book which is written for probability and random process. So just Google it, you will get several books on this. So just again explore R, and if you are easy with Python, there is no issue. You can use Python, but I would like to prefer R. Now coming to introduction to this course. So here just it is all about introduction. I am going to discuss about introduction. Why, what is probability? Why probability is coming? So this class is all about introduction class. So uh, don't bother about that. We have already started the class. Just in today lecture, I am introducing this class. So first, I would like to discuss what is probability and where we observe probability kind of things. So what is meaning of probability? So probability simply it says that it is a study of randomness. So whenever you observe randomness, then definitely you can't say things in a what certain way. Randomness, another way you can say that uncertainty. So there is always some amount of uncertainty is there. So other synonymous you can put it to uncertainty, randomness or uncertainty. So whether you measure something, if you are taking any kind of data, then what you observe, uh, you observe that data happens to be noisy in nature. It is not completely accurate. So what you observe, some kind of randomness is there, or some kind of uncertainty is there. So or you can say that uncertainty or randomness, it is of course everywhere around us. Whatever we observe that if you are not perfect, we are not perfect. It very much say that we are having randomness here. So a person can't be perfect in everything. So definitely, if not perfect, it allows the opportunity of randomness. So there is randomness kind of things everywhere around us. Whatever you do, always you observe randomness. So one of the remarkable aspect of this course is that it touches almost every area of natural science. That natural science, what we call it, physics, chemistry, biology, those kind of things. It also touches the area of engineering. It also touches the area of social science, even pure mathematics. So randomness is coming everywhere. So whatever you are going to study, everywhere randomness is coming. It is all about the percentage of randomness, how much percentage is there. If it is very small in nature, then we can ignore that randomness and we walk in deterministic fashion. Like in linear algebra is purely a deterministic approach. Okay, but again, if we put randomness, then there is a advanced version of linear algebra that we are calling it random matrix theory, where entries are coming from some distribution. So in that time, you need to know random matrix approach, and randomness is what it is giving a freedom of being a robust thing. It is not like that you can't be a very hard bomb. So if you are putting some kind of randomness, that means you are allowing some robustness in the system. So it is more flexible to other things, or more flexible to perturbation and some kind of changes. So that's where randomness is very good. In that perspective, randomness is very good. So here the following random example from random perspective I have taken it here. So even these are just few examples. You can get several examples. I told that everywhere you observe randomness. There is nothing uh, where you can't see randomness. There is nothing. So only one concept people used to say that if you observe motion of planet, there you won't observe any randomness. Otherwise, definitely there would be collapse of this system, solar system complete. Definitely it will be collapse if there would be some randomness or something like that. Definitely it might have collapsed. So we always see the same pattern. Everything is happening in sunlight and sunset. Everything is happening in the same process. So that's why there is no randomness in the motion of planet. Otherwise, everywhere you will see randomness. So, like if coming to physics, so quantities such as temperature, pressure arises as a direct consequences of random motion of atoms and molecules. In chemistry, you might have already studied that how molecules react to each other. How they, if you are taking a solid kind of structure of a molecule, how even in solid structure molecules moves in a random. So that means they are having some kind of random movement of molecules, and due to that change of temperature or change of pressure is happening. So all these we can feel that from physics. Also, if we are coming to biology and medicine, again we can observe randomness. Like random mutation are the key driving force behind evolution, and which has led to amazing diversity of life that we see today. Always you can observe that the evolution of this simple human being, you can observe lot of changes. It is not, you can't see exact pattern what initial human being used to have. Definitely there is some kind of changes. Why this change is happening? It is happening due to random mutations. Some kind of now we can observe that our height has been reduced. In previous, that all the people, they used to have very they used to have taller, and they were taller, but now height has been reduced, and life span that has reduced, and life cycle is also changed. It is not as usual uh, uh, like all the time. So random mutation. So in biology, always you observe some kind of random mutation. So it is a random phenomenon. So random order essentials in understanding the spread of disease. So even that pandemic, in this current pandemic situation, you have already heard some kind of modeling, mathematical modeling concept, that people are trying to model this coronavirus and trying to predict uh, that population, that how much population will be infected. So used to that in order to model a pandemic, uh, any kind of disease or the spread of disease or pandemic situation, then what they do, they try to divide population into three classes. So one class we always call it susceptible class, another class is infected, and third class happens to be recovered class. So what we SIR that we used to say. So what is it? So total population almost happens to be constant at the time, but what is happening? The that number of infected people, number of recovered people, number of susceptible people, all this happens to be random in nature. It is changing. They are dynamic in nature. A randomness is there. So always, if you try to model that, randomness is coming. So random model is coming. Some kind of noisy things, or some kind of white noise. At least white noise we need to introduce in order to model a spread of a disease. Unlike even you are going to uh, that one is that population modeling. What we do, we are trying to model it from it is outward model. But if you try to look inside the human body, then what we observe? So we observe how growth is happening inside the body. Like one disease is cancer. Cancer, you might be aware of that. Cancer is that it is talking about uncontrolled growth of tissues, or uh, and it is talking about uncontrolled growth. So when something, a lot of phenomena is happening inside our body, but what is it that if something is happening in control, uncontrolled way, that the body can't control, so that term as a cancer. So cancer is really, it is not creating any new kind of things. It is just making your growth rate of some kind of tissues very high. So that's where cancer is happening. So we can observe a lot of randomness is there, so to try to understand this way. So I think medical science is really right now this day working very good in order to understand all these dynamic pattern through random models. So all these things you can observe